In this assignment, we'll be modeling this staircase with, with a handrail. So as usual, let's take a good look at the drawing first. So we can see that this distance is 4 meters, and the distance, which is the width of the staircase itself, is 1 meter in that direction. Then we see that the stringer profiles are UPE 200. You can see over there, like that. And this starts from here. There's a little vertical stub coming out. That's also UPE 200. Then it goes like that, and then it connects with the column over there, and that beam is also a UPE 200, basically the same as the stringers. And of course, we have it mirrored at the back as well. Then we have the two columns, which are rectangular hollow sections at the back. We have a few beams. We've got a vertical bracing as well. Then basically we have the handrail over here. So if we come to the top over here, we will see that the handrail sections are CHS 42.4 by 3.6. All of them are the same, which means the handrail and the stanchions, the posts, they're all basically the same. There is no toe plate, so we won't be worrying about that. The dimensions here are given, the extensions, the distance between the posts are 750 along the stringer, like that. And then as you get to the floor level, then the distance between the two stanchions over there is 500, and it's equally spaced. So we've got 250 on the left and 250 on the right. As far as the stanchions or posts on this one, on the inclined one, are concerned, they also have 750, and we've got 250 at that end and 200 at this end. So you can model it like that, but since you're going to start off by modeling the stringer, so this distance is given at 750 over there, but the stringer distance at the end is not given. Whatever that is, this one needs to be the same. So whatever is left basically is applied to both sides. This width was 4,000. The floor at the top, the width is 1,000. So basically the run will be 3 meters and the rise will be 2 meters, as you can see over here. So just taking a good look before we start. This is a view from the top of the floor at elevation 2000. Once again, some of the dimensions are given. We just need to, so this is the back side, the view on line B. We see that the vertical brace, its working point, its definition point was over here, but it was shifted down 70 millimeters because this is an IPE 140 with a height of 140, so it's half of that would be 70. So this one has been shifted down, but not by actually entering it over there, because we know in COMOSYS we try to preserve the finite element model. So we'll enter it from this point, but then we'll adjust it 70 millimeters below, as shown. Let's take a look at our notes over here. No need to model the elbows. Well, we can actually, but since it's not really part of this particular assignment, the stanchions are placed in the middle of the stringers as shown. So we can see that we have a section over here, AA, which is looking down on the posts as it sits on the stringer. That's that one. So you can see that the post coming out of the top of the stringer is placed in the middle, 40-40 on both sides. This 80 is basically the flange width of the stringer. And this BB is the other section over here, where the post is sitting on this beam IPE 140, and that one has a narrower flange. So this one would be sitting in the middle like this with these distances 37. Of course, the beams are entered as the I-beams are entered with the middle arrangement as usual, middle behind. But the stringers, as you know, are UPE profiles, so they will be entered from the back side, from this side. The definition line will be passing through this line, basically. And at the end, we would like to also ensure, as always, that the model is connected in the line mode view because in COMOSYS we always want to eventually make use of technologies like IntelliClone. So we kind of make sure that in the line mode, our model looks like this. Everything is, the post actually connects to the stringer. It's not like the post is offsetted by some amount in the line mode. In 3D, it will be offsetted, but as far as the definition is concerned, it will sit exactly on the stringer. So those are the things we'll be careful about, and we'll try to now actually model this. So let's start with the columns. So the column section was RHS 120 by 5 millimeters, and they're 2 meters high at the backside. So we go to our model. I've already defined the grid as 0, 4000, 0, 1000. So we can just place the 2 columns like that. We can select them. Let me just double check it's 120 by 5. So we click on the columns and we go inside and we find the section RHS 120 by 5. That's the one. It says select. And we enter this distance to be 0 and 2 meters because we know the columns are 2 meters high. So there we go. The columns are entered. We can go back to the drawing now and start with the stringer, for example. So the stringer profile was UPE 200, but we've got this little stub coming out, and the height of the stub is 200 millimeters. And then from there, it's going to continue, and it's going to have a run of 3 meters and a rise of basically 1 meter behind this point of the column. So let's try and do that. So we can enter a beam initially to enter the vertical element. We can just click on this and hover over this one and say DZ 200, which was the height of that column. And then what we can do is we can double click on this and we can change that to UPE 200. And we know the rotation would be like that. Press Control Q twice, and then it would be, so press Control W once to get it there, and press Control E twice to basically make it sit like this. So once we have that, we can change its beam group to a stringer. We can do that at the end as well, but it's a good habit to keep doing these things. And then we can enter the beam again from this point. And we come to this point, but we know it's 1 meter before that point. So we hover over this point and we say enter, and we say dx minus 1000. And there we have our beam. And then we can continue like that. And then once both are ready, we can select them, right click, say match elements, click on this one. Now, the reason why it didn't exactly match is because there's a different algorithm for vertical elements and for all other elements. So whenever you're matching to a vertical element and the element being matched is not vertical itself, you might get a slight change. So all you need to do is just press Control Q once and press Control E twice and Control W as well. So yeah, there you go. So now this is sitting exactly where it needs to be. The beam group has also been adjusted accordingly. And I'm happy with the way they've been entered. I can just select them, right click, say copy mirror, and I can select the midpoint of that grid like that and say run, and the other side will also be created as shown. Now let's try to enter the posts of the handrails, and these posts are 750 millimeters apart along the stringer, and then we have an X at the start and at the end, and there are 4 of these 750, so there's 5 posts basically, 1, 2, 3, 4, 5, and the distance between them is 750. So let's see what we can do about that. We can come back to the model, and what we can do is we can go to our point creation and go to the extension points command, press Shift key so that we can change the settings, and then we can say it was 750, so maybe we can say 5 into minus 750, because we need the 5 stanchions. And once we have that, then we can select this point first and then the last point over there. And it's going to give us those 5 points, where the points where the posts will be, and spaced 750. But of course, they're not centered on this whole thing. So to center that, what we can do is, well, we can select the points like this as well. We can go like that, press enter. When we click on the points over here, it tells you that you've selected some other points as well, which are the end points of the frames. But those are part related. But the free ones are the ones we just created, the 5 free ones. So we can select those. That would be one way of selecting them. And then we can just right click and say move linear in such a way that the third point, which is the middle point, the third point is moved to the middle of the stringer. This is snapping to the middle of the stringer right now, like that. So if I just say move, those points are now moved to in such a way that they are equidistant from the ends. And while I've already have them selected, I could just go right click and say copy mirror, so that I have them on the other side as well. I can actually see if what I've done is correct by measuring the distance from here to here. It's 249.28, and it should be the same on the other side, 249.28. Once again, this one should be the same as well. So basically, I now have my points ready for the stanchions or posts, whatever you call them. Let's go back to the drawing and see what the profile was. It was CHS 42.4 by 3.6. The height we know is 1 meter from here. So 42.4 by 3.6. An easy way to do this would be to initially just enter 5 columns like that, and then just select all of them, go inside and change the section to CHS 42 by 3.6. I think it was this one, yeah. So we can just go like that. And then what we can also do is, could have done it together, is just say 0 and 1000 for all of them, because they're all have a height of 1 meter. Now would be a good time to see in the line mode, pressing the Alt D twice to see where we actually are. We can turn on the nodes as well at this point to see if we have actually connected. If this is disturbing you, the little green one, you can turn that off by turning off the release symbols from here, so you only see the nodes. And you can see that in line mode, those posts are sitting exactly on the stringer. So this is exactly what we want. But of course, their location is not correct. They should be in the middle of the stringer as far as the 3D location is concerned. And to do that, if you double click on the stringer, we see that its width is 80 millimeters. This was also given in the drawing, by the way. If we zoom out in the drawing, we see that this section AA says that the posts are sitting bang in the middle of the flange of the stringer, 40-40 from each side. So what we'll need to do is we will need to double click on this, and we could just say minus 40. This could be a bit of a trial and error. No, it's not this one. It's probably this one. Let's see which one works. Yeah, that's going to work. So it's the in plane is middle 40 like that. And once we've done that, then we can basically select all of them and make them the same as this one. So they're all in the center, but the definition line hasn't changed. Once again, the definition is connecting, but the location has been corrected. And now let's not forget to, of course, change the beam group as well to a handrail in this case. There we go. So we have now our the posts of the handrail as well entered, and we can continue from this point. Let's go back to the drawing and just take a look at it again. So we have the posts in place, and we know that this extension that we have a top handrail which goes, it's a single piece. It's got an extension of 200 millimeters in this direction, and at the other side it's got an extension of 250. But it's basically the same profile, and it's extending 200 at the bottom and 250 at the top. So it's nice to have these nodes turned on because I can just snap to them. I can enter a beam if I wanted to, like that. You see that the nodes turn blue. That's a good sign. I can right click it, say match elements to any one of these, and it gets matched to that. Of course, sometimes the offsets, because of the way the coordinate system is defined, you might need to go inside and change the plus 40 to minus 40, for example. That would work. Yeah, there you go. And we had an extension of 200 millimeters or in this direction. So you click on this one and you just say 200 and you say move. And at the top end, you click on this pink one and it was 250, I think. There we go. And now we have basically the top handrail entered as shown. The middle knee plate or knee profile, if you will, is basically the same section, but it's in pieces, and it's in the middle of this. This height is also 500, so the total was 1000, and this one is 500. So what we can do is we can go back to the model, and we can define our we can create dividing points very easily, just like that, like that. So that we have the midpoints. In fact, the midpoints are already snappable, so I don't really need to do this. But what I can do is now I can go in and enter my knee plates or knee profiles, if you will. And then I just need to select them and say match elements to the top one, which is going to be a better idea. Yeah, there you go. So now we have these ones entered, and they're located perfectly. And once again, the moment I want to check everything in line mode, I can just click and see whether I've made any mistake, and everything's is connecting, and it's also correctly positioned as well. What about, let's go back to the drawing. This one is a separate piece, by the way. It's not extended because this one ends over here. So there's a separate piece with a total length of 200, which needs to be entered at this point. So an easy way to do that could be just enter a beam from here to here, because you know it's the same distance, and then just copy it, move it from there to there, like that, and you have it. And then you can just say match elements to this one, and there you have that little extra piece of extension as well. And now you can create a vertical beam like that and match that to this one, and you've got your vertical this piece as well over here. Now if we come back to the model, you see that most of that handrail, of course we need another piece over here, and we need a vertical piece over there, and we can continue with those. So since I know this extension was 250, what I can do is I can just enter a beam over there, just like that, copy, move it down from there to there, say move, right click, say match elements to this one, and I've got that one. And now I can create a vertical beam, a vertical element as well, and match that to this one. So I've got basically all my elements in the handrail ready, as you can see. Now what we've done is we've created this handrail. Don't worry about these little elbows at the corners. We'll try and do them at the end. But we've created this one, But we've got something very similar on this side. It's only that it's continuing like that, but it's mostly the same. So what we can do is we can copy this whole thing to this side, and then do the modifications needed to do the rest of it. But we won't copy them because this, if you remember, it has an offset of minus 40 in that direction. If I copy them like that, it might go in the other direction. A better strategy would be to select all these and just mirror them across the middle. And in that case, the offsets would be correctly transferred. So we can go back to our model. We can just select everything like that, press enter, select the profiles and select them according to the beam group, not by section. And it shows I've got columns in there, handrails in there, and stringers in there. I can select the handrails. It just allows me to select the handrails very quickly. And then I can just right click and say copy, mirror. This is already defined, just say run. And you can zoom in and see that the offsets are correctly transferred to the middle. And once again, the finite element model is also matching up. So this is exactly what I want. Of course, there are some modifications which need to be done over here. We don't have this element in that case, I think. Let's go back and see. So if we zoom in, we don't have that vertical element over here. We've got these two posts on that beam, and then we've got two posts at the back, like that. And then we've got some extensions as well. We'll maybe the information on those is given over here. Those are spaced 500 apart with some distances on the left and right. And even this one is spaced 500 apart. So the other ones are spaced 750 apart. Once you get to the floor, the spacing is 500. So let's go back to the model and see what we should do for that. Now, to continue with that handrail, we can come back to the drawing and see that the posts were 250 millimeters offsetted from the left and right. And similarly, on the other side as well, when it turns to the other side, it were also offsetted 250 from the axis. So we can come back, and we also note that this beam at the top on the other side is IPE 140. So we come back to our model, and we first of all immediately create this little beam over there, and we enter it as IPE 140, IPE 140. There we have it. And now we need points 250 millimeters. So we just go back to our extension points command, minus 250 over here. And then we just go from here to here, minus 250, from there to there, minus 250, from there to there, minus 250, and from there to there if we want, minus 250. And we have the points for the vertical posts over there. Once again, we can actually just copy this one if we wanted to. We could just say copy, not the linear one, the other copy. We select this point and we show this point, and then we show this point like that. And then, so we have those two. And then to get these two, what we can do is we can select, once again, copy from there, from the node to this point, Just make sure we have the node correctly there. Yes, it's we can see the blue node, so everything is okay. The only difference is that the other posts were offsetted, if you remember, 40 millimeters because of the stringer being entered from the backside. But this one is an I-beam which is entered middle, so we will need to basically remove that offset for these two. Make this 0 like that. And now we have the two, the 4 posts correctly entered as well. If you feel like it, you can quickly do an Alt-D in line mode and see if everything is sitting on or connecting correctly, and they are. So we come back, and now we can proceed with creating the top handrails. For example, we can go in and just create a handrail from there to there, and from there to there. And this one we can just perhaps match to this one like that. And this one we can match to maybe this one. Yeah, There we go. So we have the two top handrails entered. Of course, they need to be extended now. So we go back to the drawing, and we see that the top handrail is extended 250 to the left and to the right. We also have to deal with this middle one, but for the moment we're doing the top one, so 250 on both sides. So we go back to the model. We can just select this. In fact, what we can do is, because it's 250, we can just make this number 1000 and press this middle button, which will extend it on both sides rather than like that. So it's going to be extended. That would be a nice way of doing it. And we can do the same for this one as well. Press the middle button, and both of them will be extended as shown. Very neatly done. Now, the next thing we could do is we could select these two and copy them linearly by 500 in the Z direction, so that we have the middle one. But of course, that's shorter. So what we'll need to do is we'll select this over here, make it 500, press the middle key, select this one like that, press the middle key, and basically we have those two elements entered as well. Coming back to the drawing, we see we are still, we want to enter this little piece over here and this little piece over here. So let's go back to the model. Let's just click on this one, snap to that point, hover over it, press enter, say dx minus 250, like that. And then for the other one, we can snap to that point, stay over that, say dx 250 in the positive direction this time. So we've got the two beams over there. Just select them, right click, say match elements with this one. And okay, some of them don't work all the time because the opposite direction. So what you would need to do is click on that, because of, this happened because of the order in which we chose the points. So there we go. We can correct that very easily. And for this one as well, once again, we will, because this is the Y direction now, I can click on that, hover on that, say dy 250. And for the other one, I'm going to say click on it and then hover over it and say dy minus 290. Why am I saying 290? I'll just show you in a second. Let me just quickly select these match elements to this one. Okay, this one worked out fine. The reason why I did minus 290 over here was, if I go back to the drawing, on this side, you can see that these pieces are actually extended beyond the axis, which is the 250 point. And the reason why they do that is because the vertical ones are sitting on the stringers with the offset of 40. So 250 plus 40 will be 290. So they need to be extended about 290 to get to that point. Don't worry too much about that, but that was just the reason why we did that. So now we have basically our basic posts and handrails and the pieces over here. All of them have been entered. I can turn off the nodes to make it a cleaner look. I can click on Alt D to see the line mode. Everything looks okay. So I'm doing good so far. At this point, we basically are missing this beam, the IPE 140, which is going from there to there. There's another IPE 120, which is at the midpoint of the column, going across over there. And if we zoom out and go to the section over here, so this IPE 120, which is in the middle of the column. And then there is a RHS 40 by 40 by 4 brace section over here, which needs to be shifted 70 millimeters. So let's start off with this one, the IPE 140 at that point. And let's take a better look at where exactly it needs to be. This is the IPE 140. It needs to be shifted to the left so that the definition point will be over here, but it will be placed to the right of that point. IPE 140. So we just go in and we click on, we can turn on the nodes if you feel more comfortable with that, just to see as to which point is which point. So it was an IPE 140. Like that, but it needs to, you need to press Control E twice to make sure that the left point is sitting at, as it was shown over there. The other one, which was an IPE 120, I think, all you need to do is just say hover over this point, say DZ1000, like that, and then hover over that point and say DZ1000 again. So you have the beam ready, and then it was IPE 120, if I remember correctly. There we go. And we also have a brace, which goes like that. So we need to go to our vertical braces. By the way, this one also was centered. Let me go back to the model. There we go. So this was not entered as behind. So if you notice that the 1000 distance is not the top of the steel, it's the middle of the steel. And then we have an RHS 40 by 40 by 4 coming on top of that. So first let me modify the, instead of keeping it behind, let's call it middle, like that. And now we can enter the vertical bracing from the node, the red one, the red snap is the node, to there. We can modify it to an RHS section. It was an RHS 40 by 4, I think. Yeah. So there we have it. It's entered in the middle. That's correct. The only thing is that it needs to be shifted 70 millimeters because this one is 140, the height of 140. So because the detailing requires us to move it down, but we don't want to physically move it down. We want to use offsets. And we know that the best way to do that is to use this blob over here, which only changes the offsets of one side. So we click on that, say Z minus 140, sorry, Z minus 70, I should say, like that. And now my definition is still there. I can see if I go to the line mode, it's still connecting to that point, but physically it's been the 3D positioning has been moved down. So that's basically the point where I'm. So one thing I forgot over here is this vertical needs to be deleted. That was copied from the other side. There we have it. These are basically the elements which we needed for this assignment, and I think we've entered almost all of them or all of them at this point. Now, if you wanted to just make your model look good with those elbows over here, you could just come to the steel menu, and there's this thing which basically connects two pipes with a little elbow, and it's got a file associated with it. We won't be talking about that at the moment, but just to show you, just click on this, click on that, and you will get that little elbow over there. Click on this and that, you'll get that elbow over there. Go over here, this one and this one, you'll get that. This one and that one, you'll get that. This one and this one, you will get that one. Hopefully this one will also work. There you go. Between this one and that one, there you go. Between this one and this one. So I think we've got most of them. No, we don't have all of them, right? This one and that one. And basically we have the whole structure modeled as required by the assignment.